Hello everyone, welcome back to our YouTube channel. Today we are going to build something super fun, a meme creator. So we are going to download this in the Swift Playground and open it. The very first thing that we are going to do is create the panda model. Think of this as building the blueprint for every single panda that will appear in our app. This panda struct is carefully designed to match the exact shape of the JSON data that's coming from a web server. If you tap the URL right on the screen, you'll see the raw JSON in your browser. It's just a list with the text descriptions and image URLs for adorable pandas. Each panda has a description and an image URL property, which is the link we'll use later to download the actual picture. Then we have panda collection, which is basically just an array of these panda objects. It mirrors the top level structure of the JSON perfectly. Why is this important? Because Swift's built-in codable system can now automatically decode the entire JSON file into real Swift objects with almost zero extra code. No manual parsing, no headaches. This exact pattern is used in every real iOS app that talks to the internet. Instagram loading posts, weather apps pulling forecasts, shopping apps showing products, even games fetching levels. Once you master modeling JSON like this, you can connect your app to almost any web API in the world. So take a moment to look at the code. See how clean and simple it is? That's the power we are unlocking right now. Great job getting this foundation solid. Alright, now that we have our data model ready, it's time to actually go out to the internet and fetch the real panda information. Meet the panda collection fetcher class. This is the brain behind all of our data loading. It's marked as an observable object, which is Swift UI's way of saying, hey, whenever my data changes, automatically update the entire user interface. Inside it, we have two important @published properties. Image data, which will hold the full collection of pandas once we load it, and current panda, which is the single panda we are currently showing on the screen. The UI is watching these like a hawk. So the moment new data arrives, the image and description update instantly. The star of the show is the fetch data function. Notice it's marked async and throws. Async because network calls can take a second or two. We don't want the app to freeze while waiting. And throws because things can go wrong. Bad internet, server errors, you name it. Inside, we first check the URL is valid. Then we use the URL session.sharedData.for with await. The await keyword is magic. It pauses just this function while the data downloads, but the rest of your app keeps running smoothly in the background. After we get the data, we check that it really comes from an HTTP server. We verify the status code is 200, that means a success, and finally decode the JSON straight out into our Panda collection. This is exactly how every modern app loads live data. Twitter timelines, news feeds, stock tickers, fitness trackers. Without async await, your app would lag horribly. Now run it and watch the preview light up with real pandas. Pretty cool, right? You just build a live data pipeline. Great, we have fetched the data. Now, how do we get that data into every view that needs it without passing it around like a hot potato? That's where .environment object comes in. Instead of stuffing the panda collection fetcher into every single view manually, which gets messy fast in bigger apps, we pass it once at the top level as an environment object. Now any subview can simply declare @environment object var feature, Panda collection feature, and instantly have access to the latest data. And because it's also an observable object, every view that's watching it updates automatically when the data changes. This is one of the most powerful uh, patterns in Swift UI. Real apps use it for shared things like user login status, shopping cart contents, settings, theme preferences, or live scores. One single source of truth, zero duplication, and everything stays perfectly in sync. It's clean, scalable, and it makes your code feel professional. So remember this trick. You'll use it in almost every app you build from now on. Networking is powerful, but it can also fail, and nothing frustrates users more than a silent crash or blank screen. So let's be kind to our users and show helpful error messages when things go wrong. We start by adding a simple state property called error message to hold any problem text. Then right at the bottom of our VStack, we add a conditional text view that only appears if the message isn't empty. Super simple. But here's the key upgrade. We replace the old try, which silently ignored errors, with a proper do catch block around our fetch data call. Now, when something fails, we catch the error and set error message equal to error.localized description. Suddenly, the user sees exactly what went wrong instead of staring at a blank screen, wondering if the app is broken. This tiny change is huge in real apps. Think of the friendly, no internet connection, tap to retry. Messages you see everywhere. Users love apps that communicate clearly. You are not just fixing a bug, you are building trust. Try breaking the URL later and watch your message appear. Feels good to be a thoughtful developer, doesn't it? Before we move on, let's do something that every good developer does deliberately break things to test our error handling. This is called simulating errors, and it's one of the best ways to learn. Try changing the URL to a fake subdomain that doesn't exist, or to a file that's missing. Finally, then watch the app preview update. Boom, your new error message pops up instead of the app just freezing or showing nothing. Do the same with the non-existent file. See how gracefully it handles it? Finally, remember to switch the URL back to the correct one so everything works again. Why do we bother? Because in the real world, servers go down, network drops, APIs change. Testing errors now means your finished app won't crash on users. This quick experiment builds confidence that your code is robust. You are thinking like a pro already. Let's make our error handling even smarter. Real network problems happen all the time. The server might be unreachable, too slow, return a 404, or send something unexpected. We already catch errors, but now we improve the fetch error enum. We change failed request to carry the actual status code, like 404 or 500, and we make the whole enum conform to localized error. So this int variable here means we can pass the error codes, and for the enum to work we also need to pass the localized error variable over here. That gives us a nice human readable description for every error type. Now when you throw the error, you can include the exact status code, users, and when you debugging, get crystal clear messages like server returned 404, the file wasn't found. And this is exactly what professional apps do. It saves hours of debugging and keeps user happy. Change the URL to a bad file again. Watch the detailed message that might show up later. Then switch it back. You can see the error code just shows up. We can see the 403. Now we need to switch it back. And let's see, this is going to, okay, we're fine. We don't have the error showing up anymore. You have just leveled up your error game. Even when the server says success and sends data, things can still break. Maybe the JSON is malformed or a field is missing. We need to handle that too. We add a new bad JSON case to our fetch error enum that wraps the exact decoding error. After adding the case, we can see that it returns a string that shows the appropriate message regarding the number. Then we wrap the JSON decoder call in its own do catch. If decoding fails, we throw our custom bad JSON error with the full details. Now try swapping the URL to the broken JSON. So one panda missing is missing its description. So you'll see a clear message explaining exactly what went wrong. This teaches you to always expect imperfect data from the internet. Third-party APIs are never perfect. By handling decoding errors gracefully, your app stays stable and you can debug issues lightning fast. Another pro move unlocked. Don't forget to change your URL back so that you don't keep seeing the errors again and again. Now, after our clean data is loaded, we will show those cute panda pictures in our app. We build a reusable, loadable image view using Swift UI's built-in async image. Async image handles downloading the image in the background completely automatically. We pass it the panda's image URL, and then we use the phase parameter to decide what to show. If the image arrived, display it with the description as accessibility text. If there was an error, show a friendly oops view. While it's loading, show a spinning progress view so users know something is happening. No third-party libraries, no complicated code, just pure Swift UI. This is how every photo-heavy app, Instagram, Pinterest, Unsplash loads images today. It keeps your app buttery smooth even on a slow connections. Run it and watch the pandas appear magically. Now the exciting part. Everything comes together in the main meme creator view. This is the heart of our app. We grab the feature using @environment object. Then we use the .task modifier to call fetch data automatically when the view first appears. Inside, we use try, await so it runs asynchronously without crashing on errors. The UI uses loadable image to show the current panda plus a text overlay for the meme text. We have @state variables for meme text size, and text color that update live as you type or adjust the slider and color picker. The text field even gets focus when you tap the button. A random panda button pulls a new one from the collection and updates instantly because current panda is @published. The whole view is reactive magic. You just built a fully functional meme maker with live images, editable text, and smooth updates. Exactly like the mini Instagram or meme apps people use every day. Play with it and have fun. Awesome work. Now let's reuse everything we learned with a brand new dataset. Real world panda locations around the globe. Look at the new JSON. It's an array of places, each with ID, name, address, latitude, longitude, and an image name. We create a panda place struct that matches it perfectly. It's identifiable for Swift UI, lists, and maps, and codable so we can decode JSON automatically. We add the previous properties name, address, latitude, longitude, image. Then two super handy computed properties location that turns latitude longitude into CL location coordinate 2D for the map and image URL that builds the full web link to the panda photo. Same modeling skills as before, just different data. This shows how flexible the pattern is. Maps, restaurants, events, stores, you name it. You are now ready to model any JSON API in the world. Same powerful fetching pattern, new model. We create panda places fetcher with @published places array. We point it at the new JSON URL. Use JSON URL session with await, then decode straight into panda places dot self inside a do catch. If it succeeds, we update the array on the main actor so the UI stays perfectly smooth. Notice how little new code we wrote? That's the beauty of good architecture. Reusable features and models mean you can add entirely new features in minutes. Run it and watch the places load. We are building real app now. Time to visualize. In Panda Places view, we import MapKit and display a beautiful interactive map. We define an initial geographic region. Then, the map automatically places an annotation, a little paw print, at every panda location using the computed location property. Tap or click on any pin letter and you'll get more info. This is exactly how apps like Google Maps, Pokemon Go, or travel apps show locations. You turned boring JSON into an interactive world map. Huge real world skill unlocked. Quick and easy switch time. In Meme Creator app, we add a new @state object per places feature. Comment out the old Meme Creator view and replace it with Panda Places view, passing the new feature as environment object. The preview instantly shows pandas scattered across the planet. This demonstrates how modular SwiftUI is. One small change and you have swapped an entire feature while keeping everything reactive. Professional apps are built exactly like this, clean and powerful. Time for the final polish. Let's make the map interactive. We add @state is showing pop over to control when the detail view appears. When you tap a place button, we set it to true and use the popover modifier to show place popover view with the name, address, and panda photo. Then we also animate the pin getting bigger when selected. Try tapping around, find the tiny panda for a fun surprise. This pop-over seat pattern is used everywhere: restaurant, details, product info, profiles, event details. You have now built a complete location-based app with maps, images, live data, and clean error handling. Congratulations, you have gone from zero to a professional grade Swift UI app in one playground. These skills will take you anywhere in iOS development. You did it. This and now for the final, let's see how it looks. Here we can see our whole map that we used from the map UI kit. Let's go to China and select this. This is the pop overview. It is using the is showing popover function. And it is also animating it. We can see the pandas over here in Berlin. We should have a panda. It's taking time to load, but that's the thing. It's using async and await. It shows what is happening, the loading function. Thank you for watching this video. We hope you learned something new. We'll see you in a new video. Please like and subscribe if you found this video useful and if it helped you to become a better software engineer or programmer.